Okay, so good morning to everyone. Now, in last class, we have discussed about the multiprocessor system, and that in the multiprocessor system, the interconnection network in the multiprocessor system, we have seen that there are 5 types of present, and among them, we are already discussed about the first type, that is the bus oriented system, time sharing bus oriented system. So we will discuss in today's class about this 4 interconnection structure. So the second interconnection structure is the multi-port memory interconnection structure. This is the second type of interconnection structure. Now, in the multi-port memory system, employs separate buses between each memory module and each CPU. Now we have seen in our time sharing bus system that there is the shared memory. Now these things, this is improved, or here we have done what, this shared memory, the memory will be the single, this is will be the shared, which we have seen in the bus. Same as that, there will also in the multi-port memory interconnection structure, the memory is shared, but we divided that shared memory into memory modules. Now we divided this whole memory, this shared whole memory into modules, memory modules. So this shared memory, we are seeing that in our structure, that the shared memory in the bus oriented system, we have a shared memory, simple shared memory present. But in the multi-port memory interconnection structure, we have divided this shared memory into n number of memory modules, into n number of module, memory module, and we have CPUs present. So we know that multiprocessor system has more than one CPUs. So here also what we have done, there is the m number of CPUs present. We are considering that m number of CPUs we have, and each CPU will able to access each memory module. This is the advantage, that we divided the shared memory into n number of modules, and we all know that it is a multiprocessor system, so multiple CPUs should be present. So we are considering that m number of CPUs present. Now what is the advantage? Each of this CPU can access each of the memory module. Now, if let's say this CPU1 can access the memory module 1, this CPU2 will also access the memory module 1, CPU-M, this can also be able to access memory module 1. This CPU1, it can access the memory module 2, CPU2, it can access the memory module 2, CPU-M also can able to access the memory module 2. Then CPU1 can access the memory module 1, CPU2 can access the memory module N, then CPU-M can access the memory module N. So that means each CPU can access each memory module. But if you see that there will be the problem happen. What will be the problem? Now we know that at a time all CPUs cannot access the same memory module. It cannot happen. That let's say CPU1 is accessing the memory module 1. In that time, if CPU2 and CPU-M, both CPUs, or let's say CPU2 want to access the memory module 1, then it have to wait, because at a time we know at a time one CPU can access one memory module, that the processor will able to access at a time. One processor can access at a time. So it is not possible that each memory module can access each CPU can access the same memory module at a particular time. It is not possible. So for this reason, we have some inter-control logic. We have some inter-control logic present. Now, what does this inter-control logic do? This inter-control logic decide which CPU will access which memory module in this particular time. So this intercontrol logic will determine that now which CPU will access the which memory module. Let's say through intercontrol logic, it is determined that the CPU 1 will at this moment will access the, let's say, memory module 2. CPU 1 will access the memory module 2. So other CPUs, what other CPU will have to wait to access the memory module 2. When the CPU 1 will finishes its task of execution, for execution, when it will complete its task, then only we can able, the other CPUs can able to access the this memory module too. So there will be the intercontrol logic present, and this intercontrol logic determined, this intercontrol logic determined which will access the memory at this given time. Now how this will be done? This will be based some priority. So priority, in case, what will be the priority? Like, let's say this task should be finished before this before the second task. So in that time, let's say the job or the task which came, like say job 1 came, and this job 1 or the task will be executed by the CPU 1, and job 2 or task 2, let's say job 2 or task 2 which came, it will be executed by the CPU 2. So let's say first there is a priority given that job 2 should be executed first, that job 2 before the job 1 should be executed. In that time, based on this priority, based on such a priority, that which CPU will access the particular memory at this given time, it will be based on the priority. So the memory module has, this memory module will have some intercontrol logic, and this will determine which part will have access to the memory, or which processor, or let's say which CPU will access the particular memory module. So in this memory module, there will be inside this, there will be an intercontrol logic present. This will determine that at that particular moment which CPU will access to it, and it will be based on what? It will be based on the priority. So we can say the memory access conflicts, the memory access conflicts are resolved by assigning the fixed priorities to each memory port, because each and every memory module, there is some intercontrol logic present. So that's why this conflict should be, we say this conflict should be avoidable. How? Because this will determine which CPU will access this particular memory module at that particular moment. So it will give the permission to that particular CPU. Another CPU will do what? It will wait. This is what this is. So we can say through intercontrol logic, or this, the memory access conflicts we have resolved by assigning fixed priorities to each memory port. This is the through this intercontrol logic. Now the advantage of this is what? The advantage it is high transfer rate can be achieved because of the multiple paths. Now you see there is a multiple paths present. We see that there is a multiple paths present. So that's why we can say the high transfer rate, the high transfer rate can be achieved because of this multiple paths. But there is also some disadvantage of it. Now what are the disadvantage? The disadvantage it is, it requires the expensive memory control logic. It requires expensive memory control logic and large number of cables and connection, because there is the memory control logic. We know that in each memory module, inside each memory module, there will be an intercontrol logic present, and which will determine that at this particular moment which CPU will access that memory module. So to implement that intercontrol logic, it is very much expensive, because to implement that it is very much expensive. And also you see, we have to make wires and cable connections, because through this we will access the high transfer rate, so we will make it with the our cables, large number of cables or connection will be required to implement this structure. So to implement this structure, we will require number of cables and connection. Now, if the number of cables and connection increased, that means our expense will be much more. The expensive will go much more for that. And another thing is what, it is only good for our system with small number of processors. Now for small number, if it is small number of processor, then it is okay. Let's say here we have used only 3 CPUs, or the 3 processor we have used, and only there is 3 memory module present. It's okay for that. Okay, it is not so much problem, because we have only 3 CPUs present and 3 memory modules are present. But if the number of CPUs get increased, if the number of CPUs get increased and the memory module also increased, then the number of cable connection will be required much more. So when this number of cable connection will be much more required, it will get expensive, because wires or cable, if it is increased much more, then also the structure will be complex. It will, the structure of this multi-port memory will looks very much complex, and also that what, it will be our expense will be much more, because if memory module size we have increased and the number of CPUs we have increased, then we will require much more cable connection for that, and much more for cable connection, the expense will get rise. So this is the disadvantage of that, that if we use much our for large system, then the expense will much more. But we want that always, as a user, or we always wants that our expense will be not such more, and also that the system will works fine and efficiently. So as a user, we always needs that. So but if we use here, okay, that is the correct reason, that if we the expense will go high, but it work efficiently, but the expense will go much more high. So to overcome this problem, what we have done to overcome this problem, we uses the third type. So to overcoming that, first you see, first in the bus oriented system, what disadvantage we have faced, that there is the shared memory and the shared bus that is present. So each processor at that particular time, when through this shared bus it is accessing the memory, in that time other processor has to wait. So to overcome that, we uses the multi-port memory connection. Multi-port memory connection, we able to resolve that. But a new disadvantage arises is what, that if we perform large number, if you use large number of CPUs or large number of memory modules, then we will require much more level connections and wires we will require. So our expense will go high. Now to overcome this problem, the third type came. This third type is what? This third type is the crossbar switch connection. This third type is what? The crossbar switch connection. So the crossbar switch connection is what? This crossbar switch connection, we have the same thing, the multi-port memory management system, what we have seen. The same thing here also, that we divide the memory in the multiple memory modules. But what disadvantage we have there? The disadvantage that arises there is that if the number of cables and connection increase, then the expense will go much more. So in crossbar connection, what we have done, we have decreased the number of cable connection, of the multi-port memory interconnection in the crossbar switches are used. So instead of that, what we have done now, in the, if we remember that in the multi-port memory, inside each memory module a intercontrol logic is present, and this intercontrol logic determines which CPU will access this memory module at that particular moment. Now here, and with this, with the cable they are connected, the cables and wires, with that they are connected to each memory module. Each CPUs are connected to each memory module. But here what the changes has been done in this, there is a switch is used there. Instead of that, a switch we are using, and we call it as the crossbar switch. We call it as the crossbar switch. So through this crossbar switch, instead of this intercontrol logic which is present in the memory module, we uses here a crossbar switch. Now this crossbar switch will determine, which memory module will access that particular moment by which CPU. This will determine, this CPU will memory, this crossbar switch, it will determine that which CPU will access the particular memory module at this moment. So instead of the intercontrol logic which we have present in the memory module in the multi-port memory interconnection structure, here we have what? We have used the crossbar switch connection. Here we use the crossbar switch is used here. This crossbar switch is used for the interaction with the CPU to the memory modules, and it decide which CPU will communicate with which memory module. This switch will determine that this CPU will communicate with which memory module. Now that means what? This connection, if we use this connection allows simultaneous access of M processor. This we are considering that number of CPUs are 1, 2 to M. So M number of processor we are considering. And here we have this shared memory. We divided this shared memory into N number of memory modules. We divide this shared memory into N number of memory modules. So we are saying that this connection, this crossbar switch connection will say that allows the M processor, because we have M processor present. So M processor access of M processor to N memory modules. M processor access of M processor to N memory modules simultaneously, and provided that each processor access a different memory. That means what? When let's say CPU 1 is accessing, let's say crossbar switch give permissions using this. Now at this particular moment, CPU 1 is accessing the memory module 1. So in that meantime, CPU 2 will do what? Let's say CPU 2 will accessing the memory module 2. Then CPU M in this particular moment is accessing the memory module N. So you are seeing that simultaneous access of memory module, it is occurring here. So this connection will allow simultaneous access. These connections will allow the simultaneous access of M processor to N memories, M processor to N memories, and this provide that each processor will access a different memory. It will that in this particular moment same memory module will be only used by one processor at a time. So other processor will do what? It can access another memory module. It will determine that. This switch will determine that. Then what is our, this is what the advantage. Now in this this small, if we see this small figure in this is the square boxes, this represent the crossbar switch. Now the advantage is what? The advantage is what? This is a simultaneous transfer from all memory modules. We have seen that simultaneous transfer, because when CPU 1 is accessing memory module 1, CPU 2, let's say, accessing memory module 2, CPU M is accessing memory module N. So simultaneous transfer is happening. So if simultaneous transfer of all modules, memory module happens, that means high transfer rate of data. There is high transfer rate because simultaneously the different operations we are performing, because the CPUs are accessing different modules at this particular moment. So it supports, we can say it supports the simultaneous transfer. It supports the simultaneous transfer from memory modules. But there is also the disadvantage. The disadvantage is, if the problem is large, if the problem now in this third type, what we have done in this third type, we have managed the expense, because instead of cable and wires we are using the crossbar switch here, and instead of intercontrol logic we are using crossbar switch, so the cost get decreased. But the another problem arises. The another problem is that if the problem is large, if the problem is large, then the number of number of crossbar switch, the crossbar switch will get increased. Now let's say, how many crossbar switch will be present here? M into n crossbar switch, because now in this case we have 3 memory modules and 3 CPUs. So for connecting 3 CPUs to 3 memory module, 9 crossbar switch are present here. You see 1 2 3 4 5 6 7 8 9. That's why we are saying that m into n crossbar switch will be present. So that means, if let's say our problem is large enough, and in that case let's say we have 16 memory modules and 16 CPUs are present. So 16 into 16, how much? We have 256 crossbar switch will be there. So it is very much problem for a large system that large amount of crossbar switch will be present. So this is the disadvantage. We have overcome the first type disadvantage there, that we have reduced the cost, but the number of switch, the number of switch get increased. This in this third type, the number of switch get increased. That is m into n, or we can say that if the number of memory modules and the number of CPUs are same, then it will be n square crossbar switch. If both are same, that the number of memory modules and number of CPUs are same, then we will require n square memory modules. But if m number of CPUs present and n number of memory modules present, then we will require what? Then we will require our m into n crossbar switch, m processor to n memory, n square cross points will require. So the hardware required to implement this switch can become quite large and complex, because the number of uh, cross switch has get increased, crossbar switch has get increased. So hardware will be much more complex, and to implement that we implement that it will be very much complex to it. So this is the disadvantage arises during this crossbar switch connection. Now to overcome this problem, we came in the fourth type. This is what this fourth type is: multi-state switching network. This fourth type is the multi-state switching network. Now till now, all of we have seen that our bus oriented system, then our multi-port memory management system, multi-port memory, then our crossbar switch, all of this crossbar switch, all of these are using the single stage network. All of them are using a single stage network. But single stage network is also, the advantage is what? Single stage network is cheaper to build, because it will be the less cost than the multi-stage switching network. The multi-stage switching network cost is much more. But both we have till now, the three types we have seen, these three types are using the single stage network. But when we have to use the multiple passes, to establish certain connection, that multiple passes we have required, then the multi-stage network should able to connect any input to any output. Now, when this such arises that we want to connect any input to any output, then the multi-stage network will work efficiently. Single stage network will not able to work efficiently. So that's why the multi-stage switching network is used. And a multi-stage network has more than one stage of switch boxes. That here more than one states, we can say more than one stage of switch box should be present there. And the multi-stage networks are a class of high-speed computer networks, which is mainly composed of processing elements or CPU on one end and memory elements on the other end, connected by the switching elements. So basically this is meaning that our multi-stage network is we have made our multi-stage network with the class of high-speed computer networks. With the high-speed computer networks there is present. And why this high-speed computer networks we require? It is mainly used for composed of the processing element or the CPU. That means in one end all the CPUs should be present, and in another end all the memory elements will be present, and they are connected with the switching elements. So if we see the diagram, it looks like that this is a multi-stage network, that in one end you see the number of CPUs are present in one end, and in another end the memory modules, all the memory modules are present in another end, and all these CPUs and memory modules are connected with what? Are connected via the switch. And we already said that multi-stage, so multiple, the name suggests that there will be the multiple stage present. And what we have said, that any input in this, any input can connect it to any output. So any of the CPU can connect it to the any of the memory module. It is like that. And there will be what? There will be between them multiple multiple stages of switch should be present. So this is what this is the saying, that the memory modules elements on the one end and the other end all the memory modules will be present. Now the switching network can connect any input to any output by making the appropriate connection in each stages. But in single stage network, we have to establish connections every time. So here any input can connect it to any output. In this, any input can connect to any output by making the appropriate connection. By making the appropriate connection in each stage, we can able to perform that. But in the single stage network, the single stage network that we have already seen, this crossbar connection, then multi-port switch, here we have to establish connection every time. So if we have to work, then we have to establish the connections every time. And the multi-stage networks are applied to build large multiprocessor system. Now till now, in both disadvantage we have seen that in each cases it is applicable for the small multiprocessor system, but in large case first time we see that cable connections increase, so the cost get increased. Then in the crossbar switch we have seen that the number of crossbar switch get increased, so the hardware become complex to implement. But when we require such large amount of multiprocessor system, instead of that three types, we should use the multi-stage network. This multi-stage network we use when the large volume or the large multiprocessor system is required. And some of that large multiprocessor system we say that are the omega network, baseline network, butterfly network, and many more. Like this, when our large number of multiprocessor system will require. In that case, example of that is the large multiprocessor system is, we say omega network, baseline network, butterfly network. Like this, when we will have to implement, in that case we will use the multi-stage network. Now in the multi-stage network, we will use the switch. Switch will be present here also, but there will be multiple stages of switch. There will be multiple stages of switch present, and there will be 2x2 switch. Now this switch will what? This switch will be 2x2 switches, and this 2x2 switches will have two possible connection. We will use what, which switch? 2x2. That means 2 input, 2 output. That type of switch we will use here in the multi-stage network. And this 2x2 switch will have two possible connections. One is straight and another one is exchange. Now how it looks like, this 2 into 2 cross switch? It will look like that. Now this is a straight connection 2x2 switch. The straight connection 2x2 switch is what? If we are giving 0 input, then the output we will get 0. If we get 1 input, giving 1 input, then the output we will get 1. Then the output we are getting 1 also. That is the straight connection, means 0 we are giving, 0 we are getting, 1 we are giving, 1 we are getting. But if it is the exchange connection, then that means if we give 0, then we will get 1, and if we will give 1, then we will get 0. So this is what? This is our exchange connection, because if we are giving 0, then we are getting 1. If we are giving 1, then we are getting 0. This is the exchange connection. This is what the exchange connection says. Now this is our 8. Now we have already said that large number of multiprocessor system is what? Omega network. So we are considering as an example of a omega network here. So this is our omega network. You see 8x8 omega network. Now what it means, 8x8? That means 8x8 means 8. Our 8 CPU will be present and 8 memory modules will be present. You see in one end all the CPUs are present from 0 to 7, and in another end the memory modules are present from 0 to 7. That means what? 8x8. That is 0 to 7 means 8, 0 to 7 means 8. So 8x8 we will say that it is the 8x8 omega network. If it is 16x16, then from 0 to 15 CPUs will be present in one end, and in the memory module in this other end, from 0 to 15 the memory module should be present. But here we are using 8x8, so that's why there is 8x8 omega network. Now here in this 8x8 omega network, if you see that first we are giving the 0 here, 0th input we are giving here, 0th input we are giving, then the 1, this 1 input we are giving here, then this 2 input is giving here. That means if you see in each switch, our first input we are giving, that is in each switch. So in this we have 4 switches present, and each switch is, we are doing what? In each we are giving the first input. That first 0 we give, then 1 we have given, then 2 we have given for this switch first input, then 3 we are given as the first input of this switch, then the 4 is given as the second input of this switch, 5 is given as the second input of this switch, 6 is given as a second input of this switch, and the 7 is what? The 7 is the our second input of this switch. This is what? This is the first stage. Now in this first stage we have already seen the 2 input which it is receiving. Now same as that, it will have output. So today it is not much time, then so that's why I will not able to discuss this wholly. So in next class I will discuss this. So till now I will again start from this omega network. From this omega network example we will again start from here. In the next class we will describe that first, and then we will move the hypercube connection. So till now, if anyone has any question up till now, anyone has any question?
Sir,
Huh.
sir, in this Omega network, sir, any CPU can access to any memory module, sir?
Any memory
Sir,
module.
sir, suppose we have sir CPU 0 wants to connect to the second memory module. So how it will, sir, access?
If it is in now it is basically what you see now, it is basically you have to connect in this stage, because it is the stage like that कि हम लोग का ये स्टेज है, ठीक है। अब इस स्टेज में क्या है कि तुम जीरो जो है वन को इधर कनेक्ट कर सकते हो, टू को इधर कनेक्ट कर सकते हो, थ्री को इधर कनेक्ट कर सकते हो, वो ठीक है। मगर क्या है कि तुम्हारा ये जो है ऐसे तुम जो बोल रहे हो कि जीरो से ये जगह में कनेक्ट करना, सेकेंड स्विच सेकेंड स्टेज में तो ये पॉसिबल नहीं है। तुमको स्विच जो है इसमें तुम जो भी इनपुट दो तो, क्योंकि स्टेज बाय स्टेज ये जाएगा। हाँ, तो स्टेज बाय स्टेज जब जाएगा तो इसको अगर जीरो को हम इनपुट दिए, वन को इनपुट दिए, ये हो सकते हैं। हाँ, हम इधर फोर दिए थे, तुम बोल सकते हो कि हाँ वन को हम कनेक्ट कर सकते हैं, टू को कनेक्ट कर सकते हैं, थ्री को हम इधर कनेक्ट कर सकते हैं ऐसे। मगर क्या है कि हम जीरो से ये स्विच में डायरेक्ट कनेक्ट नहीं कर सकते, बाय स्विच तुमको जा सकते थे।
Sir,
ठीक
is
है,
this connection permanent or it changes with the sir logic input?
this connection you can change with logic input, you can change with able to
Okay.
change with logic or clear.
Yes, sir.
Okay, now I will discuss about this whole because today